Hi, welcome back. So today's video is going to be all about diffusion. So the title of our notes is going to be that, diffusion. And what diffusion is about the movement of stuff. And specifically for this class, we are talking about the movement of molecules, and specifically we're talking about the movement of molecules into the cell and out of the cell. So all living things are made of cells, and things need to go into the cell and out of the cell, just like we have a body and we have to put things in our body and things have to come out of our body, okay? So you can think of a cell as a little tiny living organism, and sometimes that is that, but things need to go in and things need to go out. And so there are these processes that allow things to go in and out of the cell. Okay, so the two major categories for the movement of stuff the first one is called passive diffusion, and the second one is called active diffusion. So I'm going to split those up into two categories, and we're going to talk about them. So the first one is first let me just define diffusion is the movement of substances. And I just want you to know that substances move all the time. And we are just focusing on the movement of substances into the cell and out of the cell. Okay, so we've got two major categories. The first one is called passive diffusion. And what passive diffusion means is that molecules or substances are going to move naturally, and they're going to go from a very crowded area to a less crowded area. So for example, let's say that we had 100 people and they were in this tiny, tiny little room and they were all stuffed together like sardines. And then you took down a wall, you had one of those accordion walls and you moved it. And then slowly everybody would just spread out because it was just more comfortable. And so things don't like to be all squished up together naturally. And so they'll naturally just spread apart. That's what passive diffusion is all about. So what passive diffusion is the movement of substances from a high concentrated area to a low concentrated area. So I'm going to put movement of substances from a high concentration, so very crowded, to a low concentration. Okay, and so, and another thing that I want to point out is that this just happens naturally, and there is no energy required. In fact, energy is being stored when this happens. Okay, so I'm just going to put here no energy required. Okay, because it just happens naturally. Okay, and I'm going to break this concept down of passive diffusion into little subcategories. And I want to talk about simple diffusion. Okay, so I'm gonna talk about these three little categories. And so the first one is called simple diffusion. Okay, and so what this means is that it's the same concept where molecules are in a very crowded area and they just naturally spread out. So I'm going to say molecules in a crowded area. Crowded meaning high concentration. Move to a low crowded area. I'm not sure if that's even a word. Low crowded, so a more spacious area. And the example I'm going to show you for this is let's say we have a beaker of water. Okay, hang on, that's not a good beaker. Let me scoot up for a second. Okay. So here's kind of a beaker. Okay, and let's say this has water in it. Water has water molecules. And remember, the water molecules are these little tiny Mickey Mouse heads, and there's a whole bunch of them in this beaker. And then let's say we threw in a food dye. Okay, so they come in these little pellets, and you just throw one in there. And so in this water, in this beaker, we've got millions of water molecules, and we've got this big piece of dye, and there's molecules in that dye. Okay, we also have molecules in the air too, because there's always molecules everywhere. But we're just going to focus on this solution right now, which is the water and the dye. And so at this point here, all the dye molecules are all crowded up and uncomfortable. And so over time, they're going to start to spread out and mix in with the water molecules. Okay, all the water molecules are all spread out nicely because they've been sitting there for a long time. And the red dye molecules are going to individually start moving around and mixing in with the water. And so over time, what's going to happen is the water is going to look red because all the dye molecules have now spread out evenly and are all spread out. So this is an example of simple diffusion, just that things naturally spread out. And once they're all spread out, it's called equilibrium. So they've reached equilibrium, which means they're all comfortable and they're just like flowing around, moving around. Okay. This happens in the cell. Sometimes in a cell, like let's say, for example, so I'm just going to, oops, that's not what I wanted to do. Okay. So let's say we have a cell and let's say there are a lot of, I'm just going to use salt. Okay. So salt refers to any compound. Okay. It also refers to the salt that we eat, and we can think of it as the salt that we eat. There is some salt in your cells and there is some salt in your blood too. But anyway, let's just say salt. And let's say that there's a cell here and there is some salt molecules inside the cell. And let's say there's a whole bunch. Okay. And let's say outside the cell, there's not very many salt molecules. So there's going to be this need for salt to move out of the cell. So if there is a channel that allows the movement of salt, so I'm going to put a channel here, and this is a salt channel. If there is a salt channel, then salt is going to naturally move out of the cell because there is more salt on the inside of the cell and less salt on the outside of the cell. This is called simple diffusion, okay? And so salt can't move in and out of the cell by itself. It has to have a channel, okay? Because remember, the membrane of the cell is very tight. It's got these phospholipids that are very close together. Okay, so there is this other type of diffusion that's passive diffusion called facilitated diffusion. And this one also involves a channel, but this is a channel that opens and closes. Okay, this channel I drew up here with the salt is just always open. So salt can move in and out of the cell, however. Facilitated diffusion is the same concept as this salt one, except for the channel has a lid and only opens sometimes. Okay, so I'm going to say facilitated diffusion allows molecules in or out of the cell, allows molecules to move into or out of the cell using a specific channel, which is called an integral protein, using an integral protein that opens and closes. Okay, so earlier when I talked about the cell, this example I had was just an open channel. So if there's too much salt inside the cell, then salt's just going to come out automatically. But a facilitated diffusion situation, there's a lid. And so sometimes this lid is closed. And so then the salt can't move on its own. Okay. And so in this way, the cell has some control over allowing certain things in or out. Okay. So that's the only difference with simple diffusion versus facilitated diffusion, is the channel is either open in simple diffusion or can open and close in facilitated diffusion. Okay, and that way it gives the cell some control. Okay, the last thing that I want to talk about in terms of passive diffusion is this idea of osmosis. Okay, osmosis, you might have heard of this word before, refers to the movement of substances, but the substance is water. Okay, so I'm going to write the movement of water molecules. Okay, so just a little background. Earlier when I talked about the water with the dye, that's called a solution. And in a solution, you have a solute and a solvent. So I'm going to write this. This is just a little background, okay? So I'm just going to write it over here to the side. Just put a little side note in your notes. Okay, in a solution, there is a solute and a solvent. Okay, so these are just vocabulary words. A solute is the solid in the solution. Solid in the solution. So in terms of that dye example, it's the dye molecules. Okay, in terms of the salt in the cell, it's the salt. Okay, and then the solvent is almost always water. So the solvent is the liquid, and in most cases, it's going to be water. Okay, so in any given solution, the solute is the solid, the solvent is the liquid, and that's always water. And so in these examples that I gave you earlier, the solute here is the dye and the solvent is the water. Here with the cell, the solute is the salt and the solvent is the water inside the cell and the water outside of the cell. Okay, so with osmosis, we're not talking about the movement of the solute. We're going to be talking about the movement of the solvent. Okay, so that's where it kind of shifts with your thinking. And so it's the movement of water molecules, and this is important for biology because in your cells, solvents cannot move in and out of them as they want to. Okay, you have this cell with a bunch of solute in it, with all this stuff in there, like organelles and all these molecules, and they just can't go in and out of the cell as they please. Okay, but water can move in and out of the cell as they please. Water can pass through the plasma membrane. Solutes cannot, unless there's a channel, like I mentioned earlier. But osmosis is important because water does move in and out of your cells all the time. And it is kind of important to know when the water is going to move. Okay, that's why we're bringing this up. So we're talking about the movement of water molecules, and this is always with a membrane that only allows water to pass. So I'm going to write that down. So involves I'm going to call this a semi-permeable membrane. Permeable means to pass through. This is semi-permeable because it only allows water to pass through. So semi-permeable membrane. And this is what your cells have. They have a membrane that only allow water. Okay, so there are 3 situations that your cells can be in that could result in water moving. So I'm going to give you the 3 situations. The first situation is called a hypertonic solution. So I'm going to say the environment, sorry. Environment. Okay, I'm going to give you 3 different environments. Okay, so this is how I'm going to write it. Let me just erase that here. So the environment could either be hypertonic. Okay, I'm going to give you 3, and I'm going to explain it, and I'm going to draw a picture. So your environment could either be hypertonic, it could be hypotonic, or isotonic. Okay, these are the 3 options. And what this is talking about is in regard to cells in a solution, and it's only talking about the solution that the cell is in. Okay, let me explain. So in a hypertonic situation, I'm going to draw a beaker, and I'm going to, in all 3 of these, I'm going to draw a beaker, and in each beaker, we have a solution. And remember, a solution has a solute and a solvent. Okay, it's not just pure water. And then inside each beaker, we have a cell. Let's just say a red blood cell. Okay, but it could be any cell. It could be a bacteria cell. It could be a, I don't know, liver cell, brain cell, whatever. Any cell that has a membrane. Okay, and in a hypertonic solution, that means hyper means a lot. Okay, hypo means not a little, and iso means even. But in a hypertonic solution, there is a ton of solute in the solution. Okay, more solute, and I'm just going to use the word salt, but you could also think of sugar. So you could just think of anything that would be dissolved in water. Okay, so in a hypertonic solution, I'm just going to use salt because it's kind of easy to think about. There is a high concentration of salt outside of the cell compared to how much salt is inside of the cell. So let me just put some salt inside. It is way more crowded outside of the cell than it is on the inside of the cell. Okay, so in this situation, I'm just going to give you some numbers. I'm making this up, but let's say there is 80% salt in the solution. Okay, and so I'm going to say salt. This is for a hypertonic solution. And so what that means is then there's only 20% water. Okay, that's for the solution. In the cell, however, we're going to say there is, let's say 50-50, 50% salt, 50% water. Okay, so when you look at this scenario, salt can't move in and out of the cell unless there's a channel, but there isn't one in this example. But water can move in and out of the cell. So water is going to move because passive diffusion always happens. And so with water, water is the only thing that can move, the salt can't move. So because there is more water inside the cell, there's 50%, and there's less water outside the cell, it's 20%, the water is going to move out of the cell. Okay? So then what's going to happen is there's going to be a lot of water that comes out of the cell, and the cell is going to shrivel up. So I'm going to write that. I'm going to write water moves out. I'm going to write this in blue. Water moves out. Out of cell, and cell shrivels up. Cell shrinks. And this happens, right? Like if you eat something really salty, it kind of like dries you up. The water leaves. So this is true for like if you eat really salty pizza, you get really thirsty because you're like losing water because there's so much salt in the pizza. Or if you were to like when you pickle something, you put it in a very salty solution and then it gets all shrunk up. So pickles are cucumbers, and the salt sucks out all the water out of the cucumber, and then it gets all small. So that's how that works, okay? It's the movement of water. It's called osmosis. Okay, so let's talk about the next scenario, hypotonic solution. So in a hypotonic solution, I'm just going to use salt again. In the solution, there is not so much salt, okay? Low concentration of salt. In the cell, there's just like a normal amount. So in this situation, there I'm just going to give out some numbers again just to make it easier. Let's say they're in the solution. There's, let's say, 10% salt. Okay, and I'm just making these numbers up, but there's going to be a low amount. Oops, sorry. Oh my goodness. Okay, 10% salt, and let's say 90% water. So the high concentration of water. Okay, and then in the cell, let's say we have 50-50 again. So 50% salt, and 50% water. Okay, and so in this case, the water is the only thing that can move, okay, through the membrane. The salt cannot because there's no salt channel. And so the water is higher outside of the cell and it's lower inside of the cell. So the water is going to move into the cell. So a bunch of water is going to rush in, okay? And sometimes so much water rushes in that the cell bursts open. That's called lysis, when the cell bursts. So I'm going to write down underneath here, I'm going to say water moves into the cell. And the cell swells up. Sometimes undergoes lysis, which means bursts open. Sometimes undergoes lysis, which means to burst. And the pressure that builds up when water is rushing in is called osmotic pressure. Okay, and that's because it's because of the osmosis that there's so much pressure in there. If the osmotic pressure becomes too much, the cell will burst. Okay, the last scenario is called the isotonic solution. And this is where there is this equivalent concentration of salt outside of the cell as there is inside of the cell. Okay, so in this case, I'm just going to make up some numbers. I'm going to say there's 50% salt outside in the solution and 50% water. And then inside the cell, we're going to have 50% salt and 50% water. Okay, and so in this case, there's no pressure for the water to move in either direction. So what happens is the water then moves in both directions. Okay, because water is always moving. And so water goes in and water goes out at the same rate. So there's no net effect. The cell stays the same. It's healthy. This is a good situation. Okay. Okay, so we were talking about the movement of stuff. We talked about passive diffusion, and that is when substances go from a high concentration to a low concentration, and this happens naturally with no energy. The last thing I want to go over is the opposite of this. This is called active diffusion. Okay, and active diffusion is the opposite of passive diffusion. What happens is substances go from a less crowded area to a more crowded area. So it's going against the gradient is what that's called. And so it's going against nature. Okay, so let's write that down. When substances go from a low concentration to a high concentration. Oops. And this goes against what it wants to do. It doesn't want to do this. For example, if you think about the beaker with the dye, it would be as if all those little red dyes went back to the pellet and formed the pellet back. And that doesn't happen naturally, right? So that's not something that happens. So because of that, you need energy for this to occur. So active diffusion requires energy. Okay, and so let me just give you an example. So let's say we have a cell, and in every case of this, so water will never do this. Okay, we never see osmosis happening like this. But oops, sorry. I meant to just do, okay, energy. Okay, so we have a cell, and we have to have a channel, and it's called, and if you are going against the gradient, these channels are called pumps. So I'm just going to put a little arrow here. I'm going to say integral protein, and it's called a pump. We're going to see this in coming videos when I show you real examples. But let's say, for example, the cell wants some calcium. Okay, so I'm just going to put some calcium ions in the cell. And let's say we have a lot of calcium ions inside the cell. So calcium is Ca, and they're ions, so they're positive ions. And so let's say we have a lot of calcium inside, not so much calcium on the outside. And so the calcium is not going to want to go into a crowded cell, but the cell needs calcium. So it's going to use energy to grab these calcium molecules and pump them in. So this pump is going to be just pumping them in against the gradient. And this is going to require ATP, and your cell makes, energy, and that energy is called ATP. Okay, so I'm going to say integral protein is a pump, and this requires energy. I already wrote that. So I'm just going to put in parentheses here that the energy that the cell uses is called ATP. Okay, that's it for this video. Have a great day, and I'll see you next time. Bye-bye.